A massive modern institutional campus generates an immense daily volume of liquid and organic waste. The physical scale of these facilities requires specialized logistics just to handle the baseline output of thousands of residents. Conventional municipal planning approaches this output by treating water provision, waste management, and local hygiene as completely separate operational silos. This schematic maps the resource flow of a standard human settlement. Clean resources enter the system efficiently, but they exit the boundary as a highly toxic, heavily mixed sludge directed into a single centralized drain. This linear model drives severe macro-level consequences. Pumping in constant fresh resources while flushing away mixed waste leads directly to excessive external freshwater consumption, rapid groundwater depletion, and the total loss of valuable organic nutrients. By mixing disparate waste streams at a centralized municipal level, city planning turns potential resources into costly, untreatable liabilities. AliveCycle is an environmental infrastructure service engineered to replace this linear model. The core mechanical logic relies on intercepting waste streams at their exact point of origin, stopping disparate materials before they have the chance to mix in a municipal drain. By halting the waste at the source, AliveCycle installs a decentralized closed-loop recovery system that operates strictly at the local level of individual wards and residential societies. Transitioning to this localized architecture stops the perpetual drain on municipal services, shifting an urban settlement from a waste disposal burden into a self-sustaining, resource-generating asset. This 3D model of a residential block isolates the internal plumbing network, allowing us to examine the liquid waste streams independent of solid refuse. The high-volume, low-contamination output originating from wash basins, laundry, and showers is known as greywater, highlighted here in blue. The dark brown highlights represent blackwater. This is highly contaminated output originating strictly from toilets and chemical waste. Standard drainage systems experience a precise mechanical failure inside the walls. The low-contamination greywater and high-contamination blackwater merge immediately into a single pipe exiting the building. This specific act of mixing complicates biological treatment and removes the possibility of immediate water reuse. The AliveCycle water system mechanically intercepts and diverts the greywater into a parallel pipeline network before it ever reaches the main blackwater drainage. Strict source separation of liquid streams is the mandatory first step for establishing functioning decentralized infrastructure. Once diverted, the isolated greywater stream exits the residential block and enters a localized treatment node positioned directly on the premises. This flowchart diagrams the treatment node. The first phase requires pretreatment and mechanical screening to remove large physical particles from the water flow. In the second phase, the screened water passes through a biological treatment and fine filtration system for deeper chemical purification. Because the input is strictly low-contamination greywater, this biological treatment operates with high efficiency and requires a minimal physical footprint. The purified treated water is then routed directly into dedicated local storage tanks. This yields an immediate on-site supply of water engineered for controlled reuse in urban greenery, broad landscaping, and local groundwater support. Treating greywater entirely on-site eliminates the facility's reliance on external municipal freshwater for non-potable landscaping needs. Moving away from the plumbing network, the facility also generates massive solid waste outputs, specifically from institutional kitchens and mess halls. Not all solid waste is processed locally. Non-biodegradable materials like plastics and synthetics are excluded from the AliveCycle processing scope and routed to external recycling. This breakdown graphic isolates the primary operational focus, biodegradable waste. This encompasses food leftovers, preparation peels, and oil-contaminated organics. Step 1 of the AliveCycle organic waste system extracts heavy oils from the organic mass. Removing this oil prevents biological clogging during the downstream composting phase. This extraction creates secondary infrastructural potential, as the isolated organic oil can be converted into localized biofuel. In Step 2, the remaining oil-free organic matter is processed through an on-site biological unit. The system churns the wet sludge, accelerating decomposition to create nutrient-rich compost and biofertilizer. This finished biofertilizer is distributed for immediate local landscaping within the facility's own borders, or exported to support peri-urban agricultural use. Capturing and chemically processing organic waste locally prevents the methane emissions associated with landfills while actively retaining critical soil nutrients within the host community. Pulling back to view the entire institutional facility, we see both the parallel pipelines for water and the dedicated processing nodes for organics fully installed. This cyclical nodal map illustrates how AliveCycle operates. It does not treat these two waste streams in isolation, it integrates them into a unified, continuous loop. In the first half of the cycle, treated greywater is pumped directly into the facility's localized irrigation network. In the second half of the cycle, processed organic fertilizer is systematically applied to that exact same soil to chemically enrich it. This creates a direct biological synergy. The newly enriched soil acts as a high-capacity sponge, maximizing the retention and utility of the treated irrigation water. The soil and water combine to sustain the local vegetation, altering the microecosystem of the ward. Decentralized infrastructure functions as a biological engine, sustaining the localized ecosystem through constant resource cycling. Deploying this hardware requires an operational management framework to keep the decentralized system consistently online. AliveCycle functions as a comprehensive full-service provider. The model covers initial system design and deployment, as well as the daily operations and maintenance required to run it. Crucially, the service includes training for local operators and community stakeholders. This oversight guarantees long-term system performance and sustains local hygiene improvements. Looking at this operational dashboard, the integrated loop yields hard data. Every gallon of treated greywater and every pound of processed compost generates precise environmental, social, and governance metrics for water savings, waste diversion, and groundwater support. A fully managed service model transforms abstract corporate sustainability goals into measurable, verifiable environmental outcomes. Today, modern human settlements continuously generate massive, unrelenting volumes of greywater and organic food waste every single day. The municipal status quo manages this by fragmenting the logistics and draining external freshwater reserves. The structural alternative requires intercepting these waste streams at the source, capturing the material before it mixes and degrades into an unmanageable liability. AliveCycle executes this intervention by deploying a decentralized service that transforms local waste into reusable water and vital soil nutrients. Urban environmental engineering fundamentally transitions from the old logic of centralized municipal disposal to localized, closed-loop resource recovery.